Good day, everyone. Welcome to Engineering Data Analysis. Now, we had already discussed, or in the previous videos, we had already discussed the first two main topics, the engineering method and statistical thinking, and also data gathering and sampling technique. Today, we will learn about sample size determination. This will be just a short video since I will be presenting only a very common or a very simple um, a formula in determining the sample size. If you recall in our previous examples or previous videos, our sample size is already determined. Now, what if we are um, going to calculate the sample size? Now, what if we don't know or we are confused yet on what will be the number of our respondents? So we will then use a formula. There are several methods in determining the sample size. Some methods would use confidence level and so on, and other formulas. But for this video, I will only be presenting a very simple formula which we call Slovin's formula. In Slovin's formula, we only need the population of our study and the margin of error. There are cases when we don't know the population, okay, that we are studying. So just like in experiments, so there are other ways in calculating the number of sample size. In this video, we will only be talking about Slovin's formula. So this is just the slides that I have, and the formula. You have n divided by 1 plus n times e squared. N refers to, again, the population size. Okay, uppercase N refers to the population size, while E refers to the margin of error. Now here, the margin of error, we can say that this is how much we allow, or what is the error that we allow, no, in our data. So say, since, again, we will only be taking sample, therefore we are only approximating our data based on the population. So if our population is 1,000 and we only get a sample, uh, uh, we can uh, we can assume or expect that there is actually an error, and we call that margin of error. Depending on you, the lesser the margin of error, the more accurate or reliable the data, and the larger the margin of error is the more less accurate. So say for example, we have n. No? Let's say for example that our population is 400. We have 400. So how do we get our sample size? The first thing is to identify first your margin of error. Now, there are some ways in identifying that one, and also there are other methods even that we are asked to get the confidence level. But for this case, we will only be getting the margin of error. Now, what if I want the margin of error to be, let's say, our E is 5%. No, the margin of error is just 5%. So 5%. Now we cannot multiply 5% directly, so we have to convert it now into a decimal form. So that's 5 divided by 100, or 0.05. So our formula here will become 1 plus 400 times 0.05. You have to remember that there is a square there. Now what will be the result of this one? So what is 400 divided by 1 plus 400 times 0.01 square. So what do you think is the answer? So kindly check if the result is 200. Is it 200? Now, if this is the result, now if n is equal to 200, that means we need 200 participants so that we can have 95 99 no, that's 95% reliability. Now, meaning our data is the margin of error is just 5%. Now let's have, what if we will have a 50% margin of error? Now again, we convert it to decimal. That's 50 divided by 100. So we have 0.50. Okay, what will be our n if our e is equal to 50% or 0.50? Then again, we use our formula. Okay, so we use our formula. That's 400 divided by um, 400 divided by 1 plus 400 times zero point 0.5 squared. So what do you think is the result? So let's use a calculator. So that's 400 divided by 1 plus 400 times 0.5 squared. All right. And that gives us 3.96. So n here is approximately, since we don't have 0.96 person, that's 4. Okay, we only need 4, but that's um okay, that's only 4 individuals to be our respondent. That's 50% margin of error. But take note that 50% is a very large error. Okay, so you have to get smaller error, probably 10% or 7% or 5%. However, if you are dealing with processes or experiments that needs to be accurate, no, really, really accurate, then you have to decrease your margin of error. Okay, that is how we use Sloven's formula. In our late, later examples, we will make use of these. You have to check your module, okay, for the different examples or sample or problems that you need to solve. Just follow this Sloven's formula. That will be all. Now we are done with our first module. So that's the introduction to engineering data analysis, specifically statistics. So thank you and see you in the next video.